Hi guys, thanks a lot for coming down to our talk. Uh, since our has been done already, we'll just get started with the topic directly. Now, I have been building Iron Wars for close to 3 years, and I have gotten in touch with a lot of people. Every conference I go to, I speak to a lot of developers. I speak to a lot of startup founders. I speak to a lot of people who manage development teams, and one common question I get from all of them is, "Hey, Lava, I have this small software development team of 5 people, 10 people, and we come out with 5 to 10 builds of a software every quarter, and we simply do not have the budget to do security testing on all of those builds. It does not work at all for us. Is there anything that you can actually do by which we don't have to compromise the speed of our software release, we don't complicate our process, but at the same time, we make sure that every build we send out actually goes through some level of security review, and we do that without adding to our existing budget and our manpower." So this was a common challenge, I would say, most people put to me, and it's like, "Hey, can you solve this problem for us?" Now, I go to them trying to tell them how good Iron Wasp is, and then they come up, throw a challenge back at me. It's like, if it's really that good, can it solve this problem, right? So then I thought about it, and I thought, what the hell? Let's actually see if we can crack the problem. And so I asked them, okay, you make all these builds, but before you send them out, do you do any kind of QA? Do you have any kind of QA process to make sure that the code is of a certain quality? And what they told us is that we actually have a functional testing process where every build that we make goes through a functional testing process, and then it goes online, but we don't do security testing for each of them. And then I got thinking, since there is a functional testing being done on every single build, would it actually be possible to extend that process to include a bit of security testing into it as well? And to solve that problem, I had to understand functional testing properly. I'm not a functional tester, I'm a security guy. I don't know how the process works. I don't know the tooling related to functional testing. I assume most of you are security people as well. Probably you don't understand the tooling and process of functional testers also. So fortunately, I ran into Ankita in Null, Chennai, and she just happened to be a functional tester, right? So I bothered her with a lot of questions, asking her to explain what functional testing is, how it works, and how do you perform that. And she can explain the same to you guys as well.
Yeah. I'm not going to tell you in detail. So according to the definition, functional testing is a way where we validate a product on its business requirement. So it's a very overview, black box type of testing. You don't get into the internals or the structures. You don't verify anything. So typically, as an example, if we have a calculator, so one functional test case for addition feature of calculator would be give it 2 inputs and we have an output, and we need to verify whether the output is correct or not. So there are 2 types of functional testing. One is manual and the other one is automated. I'll show you both. So manual, it's pretty boring and straightforward. You go, you click, everything you do manually. I have to enter everything, all the clicks and all. So this is a demo app which we will use throughout the presentation for showing you demos and all. So who wants to meet Deepika Padukone? No one. So this is a normal manual test case. So this was a very simple test case. It had like just 10 steps maximum. But what if I have a test case which has like thousands of steps? I have to go here, there, verify so many things. So there's something called as Selenium. Some of you might be aware of it. So it's a web driver which helps me in coding whatever I'm doing manually. So we have a set of instructions. We write it, and that forces the browser and perform all our action. So the same actions which I did, I have this Selenium code, I run it, and it'll do the same things on a browser. I'm not doing anything. I'm not interfering. It's filling in the fields, logging in. So it's doing everything. So that is pretty much what a functional test is.
Okay, so as you guys could see, there was a functionality in the website, and a typical functional test case actually opens up a browser and it makes use of the functionality. And when she showed me this, it actually blew my mind away, because a common problem which all security folks have is crawling the website. That's where they spend most of their time, and that is one place where all automated scanners do a very, very poor job. Either they scroll too much, or they crawl too little. And this completely solves the problem, because it exactly goes to the sections of the site which have some useful functionality. It fills in the correct details, and it clicks on the right links, and it clicks on the right buttons. And this has been written by a human being who is in touch with the developer. So this is the best possible crawler that you could get, and this is already available with the functional testing teams. So when I saw this, the first thing I could think of was, is there any way by which I can use this as the crawler and capture the traffic, which the test case generates? And because the test case is actually run through the browser, we could. I want to know if it would be possible to change the browser setting and run this traffic through IronWasp, so that I can capture this traffic. And Ankita actually told me that's possible. Could you?
So the beauty with Selenium is, if it's possible manually, then you can code it. So how do we set a proxy in a browser? We go to settings and we set it. So using Selenium, we have functionality where we can specify what kind of browser driver we want and its properties. So here I'm setting IronWasp as a proxy, and then I'm instantiating that browser. So how do I know whether the proxy has been set and the traffic is going? So I open IronWasp, I run the case, and in IronWasp logs, the test case is running, it's the same flow. And in IronWasp logs, it's getting, everything is being recorded. So now my traffic is being routed to IronWasp.
Okay, so this, already I was making some progress. I was making use of functional test cases to some extent. I was using it as a efficient and intelligent crawler, right? And now that I have captured the logs generated by the test case, now mind you, this could be, we're just using one test case for an example. In reality, it'll be about 100 test cases which cover every single functionality of the website. Now once you run the test case with IronWasp as the proxy, and IronWasp has captured it, I could just go on and I could start a regular vulnerability scan. And this is actually done by a lot of other, I would say some tools and some companies as well, where they would have an existing software. They would, direct their functional test case traffic through that software, and then they would start a regular vulnerability scan. For example, ZAttack proxy, has a support for a feature like this. But the problem with this is, if you look at the test case, it was going in, it was filling up a form, and then at the end of the test case, it actually logs out of that particular session, right? So during this process, I capture about 6 or 7 logs, and if I were to simply scan these 6 logs, it's pointless, because the session that the logs actually belong to has been invalidated already. The test case itself logged the user out. So scanning these logs is pointless. And the existing tools that make use of functional test cases actually do this exact same thing. And that severely limits the kind of coverage that you can get from the test cases. So I went about trying to see how we could solve the problem. One way by which we could actually do that is, if IronWasp had some information about the test cases. At this point of time, IronWasp only has all the logs which are generated by the test cases. So for example, let's say 1,000 logs are captured from the test cases. There is no information about which logs belong to which test case, and any kind of context. So that was the next thing we wanted to solve, which is IronWasp should know when a particular test case started, when it ended. So from the 1,000 logs that I have, I could actually put some context saying the log 1 to 50 belongs to test case 1, the log 55 to 56 belongs to test case 2, and so on. Now again, I went back to Ankita to try and check and see if something like this could actually be done.
So I came up with a library. I am using Selenium Java, so we tested it on Java. Later on, we'll come up with it in more languages. So it's possible to call ironWasp via the test case. All we need to do is import this library, and at the start and end of the test case, we just make a call to ironWasp telling the test case this test case has started and the same test case has ended. So over here in our code, at the very start of the test case, I tell ironWasp to start workflow, and at the end I tell that workflow has ended. So that is the only change which I have done in my existing test case. We don't need to add like million lines of code, just 2 simple lines. Now if I run it, the test case is running. So this is a window which ironWasp will provide. It's a workflow scanner. It will record the data, the logs, the test case, the logs of that particular test case. So over here, if you see, the log range 14 to 19 belong to the test case demo app.test.flow. So along with the logs, we are getting to know which test case do these logs belong to.
Right. Okay, so by adding these two simple API calls, one at the beginning of the test case and one at the end, ironWasp can actually know when the traffic of a particular test case starts and when it ends. And once I have this information, I could directly start a scan of individual workflows. So I'm not just doing a dumb scan of all the thousands of logs I captured. I'm scanning them as individual workflows. Now there's an important difference when we scan them as workflows. I'll just go into that now. So now that I've started the scan, ironWasp is scanning it for different kind of vulnerabilities, and these are all the scan traffic that's being generated. Now if you look at log number 4, so this request actually belonged to the stage where the person wanted to set up a meeting with Deepika Padukone, so he entered the name of the person and the phone number of the person who was going to meet her. And when that is submitted, this actually contains a CSRF token, right? Now, this CSRF token is unique to every single session. So if I record the workflow once, and if I'm going to rerun the workflow, I would have to log in again. Then when I log in again, I'll be given a new CSRF token. And when I'm sending this particular request, I would have to send this new CSRF token. If I do not send this, then this request will not be processed by the application. Then there is no point in scanning this particular request. So when the beauty with the workflow scanner is, it actually understands all of this context. So when her library tells me that log number 1 to log number 6 belong to a single workflow, ironWasp takes all these 6 logs and it analyzes all of them, and it tries to create relations or mapping between each individual logs. It tries to see if log number 3 was actually generated by clicking on a link on log number 1, or if log number 6 was generated by submitting a form on log number 2. So it creates all these mappings, so it knows which parameters of one log should come from the response of another parameter, and it updates them dynamically when it replays them. So replaying a workflow from ironWasp is almost as good as going back to the browser and doing the same workflow again. So because of this, the workflow is performed properly with all information about the session. So your scan gets done in the most optimal kind of way. Now, normally if you were to use, or even a pen tester, if he's going to do a vulnerability scan using an existing software, he has to go and he has to either record a login session, or he has to put other kind of site information into the scanner. In this case, all of that is automatically inferred by ironWasp, and it makes use of that, right? Okay, so that's how a scan typically runs, and we have discovered a cross-site scripting vulnerability as well. So this way, once a development team has finished its build and functional test cases have been written, you make minor changes to the functional test cases, and then you run the test cases, and ironWasp would automatically take them and perform an automated vulnerability scan for you, right? So it does not really affect the company's budget in any way. They are not using extra manpower to do this, and ironWasp is free and open source as well. So you don't have to spend on the software also. So far, whatever we have done has solved the problem of identifying the vulnerabilities on a particular build. And identifying a problem is only half the solution. The other big aspect is fixing it, right? And the people who fix it are not the managers, it's not the CTO, it's the developers. They are the soldiers who actually, at the end of the day, pull the trigger. And to be fair, the security industry has been very, bad to the developers. If you look at any pen testing report which is sent by a tool or a consulting company, it would look something like this. So where you have, nice coloring of the vulnerability based on the impact, you describe what the vulnerability is, and then you would explain what would be the impact of the vulnerability. Now, this would make sense to the pen tester because this is, the only thing that the guy knows about. But when the developer sees it, the exact same text looks like this to him, right? And it's completely pointless. And this is the guy who's going to fix the problem, and all we give him is gibberish, right? And obviously, this would lead to the developers getting defensive. They start arguing about, the impact. They're like, what? It hasn't happened in so many years. I don't think it's going to happen again, right? So all these kind of unnecessary arguments actually go on. And we could actually solve it really simply by giving specific tasks to the developer instead of pages and pages of information about vulnerabilities and impacts, which those guys do not need about, don't care about at all. So how about a report like this, where you say, on this page, when you're printing the value of this particular parameter, just, do these 3 actions. This is exactly a requirement that you give to the developer. It's a set of steps that he has to perform. He does not have to, if the developer is doing this, he's actually fixing cross-site scripting vulnerability. He does not even know that he's fixing cross-site scripting. So he'll only follow the steps that you tell him. But when you tell the developer, hey, there's a cross-site scripting, alert 1, 2, 3 will happen, now you fix the problem, he'll go and write a regular expression to block alert 1, 2, 3, right? But when you give him this, he'll exactly do these steps, and the problem gets handled automatically, right? Yeah. I could put more characters, but the slide would have been, the letters would have become small, but the actual report will have all the characters. Oh yeah, so when the Iron Wasp will find out in which context the cross-site scripting is happening. If it is happening in the HTML context, so OWASP has this encoding XSS developers, XSS prevention cheat sheet, where it says on this context, these characters must be encoded into this equivalent, right? So we'll give our recommendation based on that. So during its XSS scan, if Iron Wasp finds that the data is being reflected back in HTML context, then it will give something like this with more characters in the list. But then let's say, for example, it's being reflected in CSS context. So then it will give the equivalent CSS safe, characters. So that way it will get taken care of, okay? So anyway, as far as the developer is concerned, it's just a bunch of steps, and it's much easier for them to actually fix the bugs, and and everybody is happy, right? So this is the system that we have actually come up with. The scanning part is already implemented; it works. The reporting component of it is currently being developed. It should be done probably in a week. Usually my week goes into a month, but this time I'll try to keep it to a week. So it should be out by February or at least in early March, the reporting component. And yeah, so this is a system. We have actually tested it in a live environment as well, right? So we have done it in Pinkstripe. They have a product called AlDogs. Nithya Raman is the associate director of security there. She has been kind enough to let us, test out our system there, and it actually did quite well. Yeah, right.
And we are in talk with other developers and teams to implement it.
Yeah. So we are actually, going to go to developer conferences, not a security conference. Speak with the developers and tell them, hey, the security problem you have, we actually have a solution designed exactly for you. You want to give it a shot. and then we'll see how things go from there. I have people, nice folks like Tamagna Basu, who would be helping me, in this initiative. So hopefully we should, make code more safer, I guess. Yeah. Right. So that's it, guys. If you have any questions, we would love to take it up.